We're all familiar with the concept of video. Or I should hope so, because you're watching one now. But technically speaking, how is a recording of me different from an animation? And how is that different from something interactive, like a video game? These each have similarities, but lots of differences as well. A video is a sequence of images that are shown in succession fast enough that your brain is tricked into thinking that the objects in the images are actually moving. A single image out of a video is called a frame. How fast do frames have to be updated in order for this to work? In the 1920s, the film industry decided that 24 frames per second, or 24 FPS, was just about the bare minimum that gives a sense of persistence of motion. This is still the most commonly used frame rate used for film today. Since we've been seeing it for about a century, it's what we've become used to when watching movies, and it creates a classic cinematic look. Since 24 frames per second is the minimum, let's see what happens when we go slower than that. The lower the frame rate, the less smooth the video appears. This especially becomes noticeable for fast-moving objects like this ball. Compare how it looks at a slow frame rate to how it looks at a standard frame rate. There are different standards for how many frames per second a video should be, depending on the medium for which you're making content. Different frame rates produce different-looking aesthetics. A higher frame rate makes video look more like what our eyes perceive in the real world, which is why video for TV is often shot at 30 frames per second, and video games are often 30 or 60 frames per second. But a higher frame rate isn't necessarily a good thing. A video with a higher frame rate loses that movie feel, and if you're rendering an animation, more frames means more images, which take time to render and can take up a lot of memory on your computer. When rendering an animation in software, you may be able to choose whether you want to write it out directly into a video file with a format like MP4 or MOV, or you can write out the individual frames as images and then combine them into a video as a second step. It's actually considered best practice to do this in 2 steps, because if there's an error halfway through your visualization, you can pick up the render from where it left off if you're writing individual images, but you'll have to start over from scratch if you're writing directly to video. Rendering frames rather than video will speed up your process in the long run. In addition to frame rate and the number of frames you're creating, another factor that will affect your render time is the resolution of your video. Resolution refers to the number of pixels in an image. Many screens of different sizes have the exact same resolution. Like with frame rate, there are standardized values for video resolution as well. HD stands for High Definition Display Resolution, but that isn't actually terribly descriptive. HD usually refers to a display that is 1920 pixels horizontally and 1080 pixels vertically, referred to as 1920 by 1080. That's the resolution of this video that you're watching. Sometimes this is called Full HD. HD can also refer to a resolution of 1280 by 720. You'll often see a 720 option on streaming platforms and mobile devices as a way to reduce your data requirements. 4K resolution refers to a horizontal resolution of about 4,000 pixels. This can also mean a couple different things. 4096 by 2160, which is used for the movie projection industry, or 3840 by 2160, which is also referred to as ultra-high resolution, or UHD. Pop quiz. How many more pixels do you think are in a 4096 by 2160 image than a 1280 by 720 image? The answer is about 10 times. It's actually 9.6. It may not seem very intuitive, but the number of pixels doesn't increase linearly with image size. Let's take a look at a simpler example. A 10 by 10 resolution image would have 100 pixels, but a 40 by 40 pixel image would have 1,600. Increasing your resolution by what seems like a little bit can actually be a lot more pixels and have a large impact on the amount of time it takes to create your images. Keep ray tracing in mind when doing this math in your head. For every pixel, you have to cast a light ray out and bounce it around your scene until it finds a light source. When you do that for an HD image, you're doing that calculation 2 million times. And when you do that for a 4K image, you're quadrupling 2 million. This is why it can take a lot of time to render imagery. Typically, videos are pre-rendered. This simply means that the images are not being rendered on the fly in front of you, but they may have been rendered days or years ago. If you're creating a video, you more or less have all the time in the world to render your images. You might be able to afford spending multiple hours on rendering a single image, which means you can add features to make your images as realistic or good-looking as possible. There's another type of rendering you can do that is called real-time rendering. Video games and other interactive media, including interactive visualizations, need to be rendered quickly enough that they can respond to user input. This means that the images are being created at almost the same time as they're being viewed. Real-time doesn't actually mean real time, but just fast enough to keep up with a video frame rate. About 30 frames per second is good speed for real-time rendering, though faster frame rates like 60 and even 120 frames per second are used by competitive gamers who rely on tight hand-eye coordination tasks. Historically, the visual quality of real-time imagery has lagged behind pre-rendered imagery because of the severe limitations of time. But thanks to recent advances in technology, real-time imagery in games are starting to look extremely high quality, and in certain limited contexts, look completely cinematic. This is a frontier of computer graphics. Visualizations can be pre-rendered or rendered in real time. When writing out your images, you should follow conventional standards for frame rate and resolution, but you do have options that give you flexibility. Understanding the costs and benefits associated with these design decisions will help you in planning for your project. Fun fact: slow motion video is created by using cameras that can record at a very high frame rate, at hundreds or thousands of frames per second. When you play back such a video at a standard slower frame rate, you get slow motion. Here's a video of lightning shot at 6,200 frames per second.